As data continues to shape our world, the importance of data warehouses will continue to grow. Imagine a data warehouse that scales effortlessly, runs faster, and keeps your data secure, all while offering real-time insights. In this episode of Great Things with Great Tech, I'm joined with Mark Cusack, CTO of Yellowbrick Data. We'll explore how Yellowbrick's Kubernetes-powered platform is revolutionizing data warehousing with hybrid and multi-cloud capabilities, high performance, and complete control of your data. If you're looking for a more efficient way to manage your data, this conversation is for you. This is episode 94 of Great Things with Great Tech with Mark Cusack of Yellowbrick. Oh, welcome, Mark Cusack, CTO of Yellowbrick. So, Mark, just before we get into a bit of your background in Yellowbrick, what is a data warehouse? Let's explain that first, because I think in today's day and age, data is so critical, so important, and definitely this notion of storing data in a place where you can do more stuff with it is obviously what companies are looking for. So, how does data warehousing fit into that?
Yeah, so a data warehouse is a centralized repository where lots of data from operational systems all over your business, this could be supply chain systems, financial systems, transactional systems that are kind of at the front facing end of your business, making these, closing transactions, doing ATM things and all this kind of stuff all flow into this centralized data warehouse for longer term analysis. And so data warehousing is typically associated with descriptive analytics. You're looking at for patterns that happens in the last sort of 4 or 5 quarters of your business, and then use those patterns to make predictions and business decisions to guide where your enterprise is going.
Yeah, and typically, what sort of sources are they typically coming in from? Is it generated from line of business applications or someone's other type of front end app, or or is it just basically all of the above?
It can be all of the above, but typically they are kind of OLTP systems. It's very highly structured data. They're online transactional processing sources that end up storing these closed transactions into a data warehouse. So yeah, and the data warehouse is typically, it's highly structured data. SQL is the language that's used to process that data and access it, but you arrange the data in particular schemas within the way you model the data that's in there. And so you'll hear things like star schemas and snowflake schemas, and these are really just ways that we for efficiency perspectives model the data and store the data and separate it to do that analysis more effectively.
Right. Okay. Well, we'll touch on the specifics around the SQL side of it and how the data is accessed and how it's optimized, and that's kind of why a company like Yellowbrick exists, right? In terms of optimizing that data and making it easier and more efficient for businesses to get that data out. But let's start a little bit with Yellowbrick itself. Give us a little bit of an introduction to Yellowbrick, what you guys do, and what's your value prop.
Yeah, so Yellowbrick provides an SQL data platform for satisfying these data warehousing use cases and a number of other use cases as well, which we can get into later on. But the company's been around for around 10 years, founded in 2014. We first went to market in 2017, and we went to market with an SQL database that ran on our own hardware. So we shipped an appliance that we'd install in a customer's own data center. It was very turnkey in terms of its operation. This thing would stand up and run, and they'd be able to do all of this data warehousing they would want to do in there. About 3 years ago, we actually took the software that runs within that appliance and ran it on the cloud and turned it into a Kubernetes-based application that runs now on all three public clouds. So we've actually gone on this journey from on-prem hardware into the cloud, and there's a ton of good reasons why we did that. Partly because at the time, cloud hardware really wouldn't tap into some of the efficiencies that we do in our technology at the time. It does now. So a lot of the goodness and the IP that we used to do on-prem, we can apply to cloud now.
Yes. Okay. So that's a really interesting, sort of pivot. But again, being there for 10 years, when you say you deployed an appliance, I'm just thinking about a 1RU server. It probably had the proprietary software on there. And then it allowed the data that you talked about before to be ingested into the appliance and sit there for the purpose of the data warehousing and then the SQL querying at the other end.
Yeah, that's exactly right. And the one of the things that we really focused on was very, very small footprint appliances at that time. In fact, we still sell appliances today, and I can talk about that journey and where we're going in the future on that. But it was a blade form factor. So what
Yeah.
you'd have are these really, really high density converged compute and storage units that get deployed in the data center that run our software. All NVMe SSD based storage. We're an MPP scale out data warehouse. So what that really means is we're really, really good at scaling and parallelizing workloads, whether data loading workloads or query workloads across all of these blades or in the cloud across a whole bunch of, compute instances in the cloud as well.
Yeah, I understand. So you were talking, we were doing the research, the lineage or the DNA of the company is quite interesting. Why don't you go into that? Because you've been there for, I think you mentioned about 4 years. Am I right in saying,
That's
or
right.
roughly speaking?
Yeah.
Yeah. And you're at Teradata before through an acquisition of a company that you co-founded as well. But and I'm interested in your background just a little bit, and I want to talk about your journey in this world as well. But give us the lineage of Yellowbrick, because I think a lot of people will know where the lineage comes from.
Yeah, so the founders of Yellowbrick, Neil Carson and Mark Brinicum, were at Fusion IO, so they were very heavily invested in the storage space and flash storage. And then they obviously spun up and looked at how they could add value by taking their knowledge of storage and applying that up the chain in terms of analytics. Okay, so what was really interesting was when Neil and Mark were at Fusion IO, there were a lot of data warehousing companies like Teradata and others that wanted to take advantage of flash storage in their data warehousing appliances. And what they were doing was just simply taking these NVMe SSDs, putting them and replacing the spinning disks that they had in these data warehouse appliances, and then expecting kind of a boost in throughput and a reduction in data access and latency and things like that. What they found was they weren't getting that because unlike a pure kind of storage use case, when you're doing data warehousing, you're pulling vast amounts of data out of storage and then pushing that via typically buffer cache in DRAM on its journey into the CPU. And what they found was the they were getting bandwidth, they were getting their bandwidth tied up in the memory channels that flow from the storage into the buffer cache in DRAM and out back into the CPUs. There just wasn't enough bandwidth there to take advantage of the SSDs. And so what so the core IP that really kind of led to Yellowbrick, this idea was, well, let's bypass main memory. And as we run queries, we take data straight out of NVMe SSDs and straight into the L3 and L2 caches of the CPUs directly, so bypassing main memory. And so if you do that, that bottleneck kind of disappears and you can
Hmm.
feed we have these massive hyper-threaded CPUs now, right? To
Yeah.
feed those beasts, you need to kind of cut out main memory. The long and the short of it is that we can provide kind of in-memory levels of analytics performance, but address petabytes of data by exploiting some of these tricks.
Yeah, that I understood a lot of that. Obviously, being a computer guy from way back in the caches and whatnot. I think a lot of people that's kind of like a bit over their head, but I think that's a good way of explaining the misconception I find in data warehousing is that it's all about the disk and it's all about the data. You know what I mean? It's not actually about that, because that you're getting it in there, but now extracting it at scale and with the efficiency, that's the key of what a company like
Yeah,
Yellowbrick does. So that's kind of what I took from that, right? It's that that we're not just talking about storage here; it's actually compute and memory
very,
and smarts in the software, right?
very much. And when you look at the kind of real world deployments of data warehousing out in companies, they have their workload balance can be very, very different. It can be IO bound, or it could be CPU bound, or it could be balanced as well. And so you have to have a system that's flexible enough to deal with those different kinds of use cases. Yeah.
Yeah. So the thing that I'm sort of trying to pin together is, okay, an appliance sounds like it's the perfect solution here, right? Because you, with your software, can pin it to a certain performance that is going to be consistent across the board. But when you've pivoted to the sort of cloud first software approach, you're able to deploy on the public clouds and leverage the compute power in the cloud. There's a risk in that, isn't there? But how have you managed to sort of balance that out? Because I do find that interesting that you've managed to sort of solve it in software effectively.
Well, there's always a compromise to be had somewhere, right? You don't get anything for free at the end of the day, and so you're dead right. When we have our appliance form factor, we're in total control of the storage and the networking. And by the way, the networking is incredibly important as well. I mean,
Hmm.
there are three core kind of legs to the data warehousing stool. There's the storage, the networking, and the compute, right? Those are kind of critical. So yeah, when you go to the cloud, there are opportunities and there are kind of drawbacks as well to it. I mean, the main opportunity is I've suddenly got almost limitless amounts of storage at my fingertips and limitless amounts of compute. I can make my compute elastic. I can scale my compute for my data warehousing in and out. I can separate my compute and storage and store all my data in cheap object store like S3 or Azure Blob Storage, and I can use Kubernetes as we do to do all of the orchestration to support compute clusters spinning up and spinning down and so on and so forth. And it sounds great. And these days, like I mentioned, um, we can take advantage of NVMe SSDs that are now present in compute instances in AWS and Azure and Google
Hmm.
Cloud and and claw back and use some of the IP that we do out of our appliance. We can apply that to the cloud. But there are drawbacks when you do some of that as well. You start to have to introduce caching layers because your storage is separate from your compute, and the storage an object storage is very slow. And there are a whole bunch of different things that are out of our control. The networking is typically not as good as 200 gigabit InfiniBand that we could get in
Yeah.
our appliance, for example.
So yeah, and with that, the scaling and the efficiency that the public cloud offers is obviously something you can take control of, right? And I guess that's allows you to also potentially, I guess, address customer needs without having to have the bottleneck of an appliance. So that this is my positive on the cloud is that while a customer who buys an appliance, they're kind of limited to the bounds of that appliance, and right sizing by the by if you're in the public cloud, you kind of don't worry about that, right? So you're going to just leverage all the best bits of the cloud. So that's the positive trade-off I see.
Yeah, I think that the caveat is, of course, that again, nothing's free, and you
No,
can very
yeah, yeah.
easily break the bank by thinking you can scale your way out of a problem in the cloud without some of the financial guardrails in place. So yeah, that can get expensive quickly, which is
Yeah.
really interesting. You'll see actually, I don't know if you've heard some of this sort of thinking, which is it feels like we're starting to go full circle, and a lot of companies have moved their workloads to and data
Yes.
warehousing to the cloud, and they're now thinking, maybe there are some workloads that might be better off in the data centers I've still got. And so, there's this R word, repatriation, that's starting
Hmm.
to be talked about. And this is one of the reasons why we've maintained a hybrid stance in our product lineup by being able to deploy on-prem and in all clouds, because we think there's a lot of businesses out there that want to that right size and right place their workloads for financial reasons as well as kind of data sovereignty reasons and others. Yeah.
Yeah, data sovereignty is huge. Like you mentioned GDPR in the intro part as well. But so being the hybrid cloud data warehouse platform is your kind of stance, right? So and building on Kubernetes as well. I don't think it's too surprising these days that Kubernetes is being used in this sort of scenario. But what does Kubernetes give you guys that maybe just traditional systems don't?
Yeah, it provides elasticity, which you need in a modern data warehousing solution today, with ability to scale out, scale in computing. It gives us resilience. You have that ability of Kubernetes to spin up and redeploy pods if the underlying infrastructure becomes unavailable. And the last point I think is really about portability. I mean, it's really like
Okay,
a cloud
yep.
operating system. What it's done is allow us to, you know, we took our data warehousing software out of our appliance. We ran it on Kubernetes and got it working on AWS. And then the barrier to getting it running on Azure and then Google Cloud was lower and lower each time. And
Hmm.
what's funnily enough is the next generation of our on-prem appliance will also run Kubernetes. So our on-prem appliance doesn't run Kubernetes today, it's bare metal.
Uh-huh.
But early next year, we're going to take that Kubernetes software and bring it back home and run it on not appliance hardware, but on commodity hardware on-prem. So very exciting about that. And so again, like I think the future market is people are looking for that cloud-like experience, but in some cases they want to run it themselves in their own data center.
Yeah. We've talked about the compute, the networking, obviously very important. from a data perspective, and we made a joke about data and data early on. It's interesting how we
Tomato,
all
tomato.
pronounce it like
Yeah.
that. That's it, yeah. I am Australian and the data is there, but even most Australians will pronounce it data. Data. Anyway, we digress. The data that you're storing, I'm always interested in these data warehouses, especially from an SQL perspective like this, and business analytic data that's going to help a business. How big is it? What's the footprint? Like, what are you seeing from a customer footprint? Are we talking about like petabytes of data on average, or are we talking gigs? What is the average sort of size of a data warehouse?
Yeah, and it's almost self-selecting because if you look at our customer base, they're typically larger enterprises. The kind of deal sizes are on the larger end, and the amount of data under management is measured in the tens or hundreds of terabytes, and in some cases petabytes as well.
Hmm.
I think if you're dealing with a few gigabytes of data, then Postgres is a great solution and it's free, right? But if you want to scale out and have enterprise class resilience, performance, and not a kind of a bank breaking price, then we're worth a good look at. And a lot of that is driven by the efficiency. We can do a lot of data warehousing in a tiny amount of hardware, whether that's on the cloud or on prem.
Yeah, because typically when someone thinks about warehouse, I think massive, big amounts of something, storing something. That's
Right.
kind of the warehouse. But then also, warehouse is also in modern times more about storing stuff efficiently for its next journey, right? So bring it in, store it, catalog it, make it efficient. I think that's kind of there's two separate sort of analogies that you can use for warehouse specifically. Because I kind of thought thinking it's mainly text is my sort of thinking of it. But are we storing more than text in data warehouses?
Definitely, the trend is changing, and that's partly because of the change in the nature of the sources of data. Okay, so we're seeing more sources of semi-structured data. And so traditionally, yes, it's highly structured tabular data that we're storing, right? And that's what SQL is really good at. Now we're seeing more JSON data, for
Mhm.
example, more complex data types in terms of geospatial shapes and points and lines and things like that for GIS applications. So yeah, as the nature of those sources changes, data warehouses have had to adapt over time to be able to to support these new forms. Yeah.
Yeah, it's interesting. Yeah, no, that's good. Really getting through the nuts of the why and what is a data warehouse here. So here's a question. So why another data warehouse vendor? There's a few
Yeah.
of them out there, obviously. So I think the biggest part that we're going to probably touch on is the fact that you're not SaaS, which we've kind of hit on already. But why? Why is Yellowbrick today competing with the likes of Snowflake and Redshift and everyone else out there?
I mean, the cost efficiency is a huge one, and it all goes back to the IP about how we can get data out of NVMe SSD drives directly into the CPUs as efficiently and fast as possible. That people think about, if you store that data, if you were able to store it all in DRAM and query it, you'd get super fast performance, right? You've got no I/O from the disks or whatnot in place, but you can't scale that to petabytes, right? So what we've done is rather unique in terms of in-memory performance, but addressing petabytes of data. So that's the kind of why we're different. But the other reasons why we're different are that we deliberately made a business decision in the cloud not to be SaaS. And the reason why that is what you end up doing is buying compute capacity off AWS and selling it back to your customers at a marked up value. And then that's what you mainly worry about. And we felt that we didn't want to make money from customers like that. We thought we could pass on cost savings, improvements in cloud performance directly to customers by saying, here's the software. We'll give you an automated experience to deploy in your own cloud account. So the data plane and control plane are totally owned by you, Mr. Customer, Mrs. Customer.
Mhm.
You pay for the infrastructure that you run Yellowbrick on. You pay Yellowbrick a software license fee. Okay. So but the main thing is, can we make it SaaS-like? So they're running it themselves, but it feels like a SaaS experience because of the level of
Get it.
automation. That's really what we've driven at here. So that's another kind of differentiation, as well as the ability to deploy on-prem as well, which is there aren't really many data warehousing companies these days that can do that.
Yeah, that's a very good reason as to the why, right? And I guess from the pricing, I'm looking at the pricing as well, and it isn't per user as such. It's a per vCPU. It's just kind of like it's a mix of a modern solution, hybrid, like you said, but with old school mentality around CPU pricing, and then you've got burst rates and whatnot. So I think that's an interesting. I like the sort of reason for being there in terms of not just being SaaS and what that potentially offers in terms of just recharging, well, rebilling or passing on the cost that you're incurring of your own consumption from a SaaS platform. You don't get the benefits of multi-tenancy, which drives efficiencies in revenue as such, but doesn't sound like that's what you're about, which I think is quite a unique proposition.
Yeah, in fact, a lot of our customers, for security reasons, don't want multi-tenancy. They want their data completely separate. They want the compute processes they're running separate from others, and they don't care about that. So it has meant that we've had to build a lot of automation into the software. And I'll tell you what, Kubernetes has helped massively in that. We went all in on Kubernetes, created a Kubernetes operator, which, if those folks don't know about Kubernetes, Kubernetes is an orchestration framework for container-based software. A Kubernetes operator gives you a way of extending the Kubernetes API for a particular application. So we're a Kubernetes application. And in fact, I think we're one of the first Kubernetes data warehouses out there. In fact, I think we might be the first.
Yeah, that's awesome. And it's in itself, again, leveraging modern technology, modern platforms for your advantage, but for your customers' advantages as well. Speaking of customers, what's a typical profile of your customers out there? Like, what industries are you hitting? What type of use cases is the right fit for Yellowbrick?
Yeah, and in fact, what's one common theme across a lot of our customers is that they want their data warehousing to be reliable at massive scale, typically. So they're enterprises that range in terms of verticals from some of the top global insurance companies, the biggest hedge funds in the world, the largest telcos, the biggest credit card companies, and a lot of government and federal deployments as well. So if a lot of the commonality is there is they need 24/7 access to their data.
Mhm.
Could be in some cases thousands of users and petabytes of data in one deployment. Um, Often they're involving money or regulatory oversight in some way or another. So they need to make sure, for example, I think something like 40% of all US trades on the stock market go through a Yellowbrick system, and that
Wow.
system is used on a daily basis to provide reports to FINRA. And if those reports aren't got in time to the regulator, then the hedge fund that uses that is a customer of ours gets fined. So it's really important that Yellowbrick is available, runs its analytics on time to feed these reports. In other use cases, the U.S. Navy runs us for all of their supply chain analytics. So you're talking petabytes of data, tracking and storing financial information and inventory information that could range from toothbrushes to aircraft carriers and nuclear reactors and stuff like that, and all those little bits that go into it. So all that's
Isn't that cool?
nice and tracked. Yeah.
Yeah, cool stuff and very important in today's world. Um, I think that is interesting in itself. And in terms of the real-time analytics and workload management, so is it typically someone that's getting there and sucking the data out themselves through SQL queries? Is it? I'm picturing data scientists sitting there running queries against the platform to pull the data out. But then I'm also seeing that there's an interface and there's also applications that are interfacing with the SQL query of the platform to pull data out, like that example of the toothbrush in the supply chain.
Yeah, yeah, it's all the above. So some of our customers use this as a structured data lake where their data scientists are analyzing petabytes of data using SQL or using their favorite Python tool and the interfaces you can use with Python against Yellowbrick, for example, to surface up anomalies, to use that historical data to produce new sort of financial products and things like that. So yeah, you got that kind of ad hoc exploratory analytics, I would class it as at the one hand. Then you've
Hmm.
got kind of the middle ground, which is I've got a whole bunch of reports and dashboards that are being powered on a ongoing basis. I want to make decisions for my business on the back of, in kind of real time. And then, as you say, we're being used as a foundational piece within an application stack as well. A good example of that is a customer called LexisNexis, and they have a product called Threat Metrics, which does real-time fraud detection for e-commerce sites. So if you swipe your credit card online, buy anything online, the chances are that transaction will ultimately be analyzed by Yellowbrick to help that e-commerce business decide whether that transaction is fraudulent, like proving the identity of an online customer, and denying whether, and at the end of the day, deciding whether I ship something out to that customer or not a decision is made on the basis of Yellowbrick. And in that case, we've got data coming from Kafka from these credit card transactions streaming directly into Yellowbrick, queries being run either automatically or ad hoc up the stack in this threat metrics application in order to make these kind of final fraud decisions.
Yeah, and what are the challenges that you sort of see and identify in the data warehousing industry that Yellowbrick is solving? So, what are the main challenges that like you said, you've got some pretty high profile customers there. Why are they choosing Yellowbrick?
Yeah. So a core challenge is this idea of data sovereignty, right? And where my data must live. There's a huge movement of obviously to the cloud. Every company on the planet's got some sort of cloud strategy or in some way on some part of their customer journey. But in many cases, there are workloads that will never go to the cloud, either because in a particular region of the world there is no cloud provider, and so that workload will remain on-prem for the foreseeable future. And in some cases, data is considered too sensitive to leave the walls of a data center, and so Yellowbrick is pretty much one of the only companies that can satisfy that requirement. And you look at some of our customers that, in one way or another, are all operating in a hybrid view of the world, or have moved to the cloud, or are staying on prem. And we've had customers that started with us purely on prem, and then have flipped into purely cloud as well, and others that are maintaining that hybrid stance. Others, in
Yeah.
fact, that went to the cloud and then really have decided to move back because cloud's not cheap.
Repatriation, yeah, that's right.
Yeah.
Yeah, the flexibility I'm hearing there of what you guys are offering is part of the problem that you're trying to solve, right?
Yeah.
And that takes me back to your early days, and we probably should have kind of started here at the top. We've got sort of sidetrack. I told you that could happen. Your early days. How do you find what data? Because you've been in the industry for a while in terms of this space, since 2004. So what do you think it looked like now compared to then? What's the biggest difference in this warehouse? Was it even called data warehousing back in 2004?
Oh, it was. I mean, data warehousing goes back into the kind of 1980s. So that was a very, very established term. And in fact, it's what's really interesting is sometimes we forget the historical things that were done and we end up reinventing the wheel. And I think that's happened quite a few times in the world of data warehousing. But I think there's an overarching trend that I think we're bucking at Yellowbrick, which is, if you look back in the last sort of 20 years, when I started out in this business, it was very much about, you had total control on the hardware and the software that you'd use to deploy data warehousing. There was no cloud; it was all on-prem, but there'd be kind of specialized appliance hardware for doing this. Over time, we kind of loosened the reins, and you started to get VMware, the rise of VMware in businesses, and you'd have fleets of VMs running SQL
Mhm.
Server and things like that in your businesses, and all these different silos of data. So we were loosening control. We've given up full control of the bespoke stack that we had. We've introduced VMware into the mix. We've lost some of the operating systems control. Then the Hadoop came along, and we started to give up even more control of the software. It became open source as well, and we're making the stack entirely open. And then you kind of give up control entirely, and you move to a SaaS model, where basically you say, I'm going to give all my data to a data warehouse SaaS provider to manage on my behalf, and then I will pay them to access my data, which sounds very odd. But what you've done is you've got total convenience, but you've lost control of your data. And what we're doing, Yellowbrick is saying, well, you can have the convenience, but you can have the control as well. So that's the kind of trend that I've seen. And, you've got this rise of Hadoop. And what was also interesting was, people tried to fashion Hadoop into a data warehousing solution. That didn't really work,
Yeah.
because it's efficient. Then we're seeing the same thing happen with Spark right now, and the likes of Databricks trying to fashion Spark into a data warehousing solution. My customers tell me that's not really working very well. And so we're seeing all of these kinds of trends and mistakes being made over time.
Yeah, and talk about obviously AI. We've waited for the last sort of 10 minutes to chat about AI, which I think is good in today's day and age. How is AI, fitting into the narrative of Yellowbrick, and Yellowbrick fitting into the narrative of AI?
Well, what's interesting, when I spend a lot of time on the road chatting to my customers, and they're they all have some generative AI initiative going on, and you typically the use cases are, you know, a chatbot or a virtual assistant. So when I talk to some of my insurance customers, they're working on virtual assistants to help support their actuaries when they're making and, you know, running claims processing and things like that for insurance payouts. So they want smart assistants that can help make that task more efficient and let them get to the data they need to support those claims. The same for the payment processor customers and the credit card. They're looking for smart assistants to help their analysts design new financial products and things like this. So there's definitely a trend there. And so our customers were asking us how, you know, since they've got a ton of their data in Yellowbrick, data that they want to get smarter access to, how can we help do that? And so what we did was actually add things like vector similarity search and vector store capabilities
Okay.
to the
Okay.
Yellowbrick platform.
Yeah.
That's one of the first things we did. And so, yeah, you can create vector embeddings and do vector similarity searches in data against on Yellowbrick. And then we've done some other, and we've open sourced all that. If folks are aware of one of the most common integration frameworks for generative AI is called LangChain. It's an open source project, so there's a LangChain connector for Yellowbrick available today, so people can go and play with that. And we're doing
Okay.
other work around natural language to SQL conversion. Again, that's available in open source today, and we've got some other ideas of how we're applying this for financial control and workload analysis and other areas too.
So in the context of a chatbot, you know, when RAG comes into play, retrieval augmented generation, part of that whole process. So the agent is calling some sort of, typically an API or some sort of data source. So in that sense, your customers in a chatbot are going to be calling the data that's in a Yellowbrick SQL query and
That's
pull that
right.
data through.
That's right. And so when you type your question into your chat GPT or whatever, and then, you know, what first thing that happens is that question goes off to Yellowbrick, and we do a similarity search against the embedding representing that question with the data that's stored in Yellowbrick, and then get the relevant supporting information and inject that into the prompt, and off you go and have that conversation. So we're definitely a part of that. And yeah.
And is that driving a different use case or sort of, I guess, deployment type for you guys? Is it something that you need a stronger CPU or a more sort of grunty backend for the AI stuff, or is it all much the same? It's not adding any additional pressures because you hear about AI, you know, putting pressures on traditional systems all around, like whether it be storage or computer, whatever it is. But from a Yellowbrick perspective, is it putting any additional pressure because of the nature of the data that they're trying to pull?
Well, what's interesting is putting pressure, I think, on our roadmap more than anything. And you know, you can use, you know, when you give the RAG examples that with involving Yellowbrick today, they're typically using some open or, you know, internet available LLM, like, you know, the OpenAI suite or whatever. But a lot of our customers, a lot of them don't even have internet access. They're running dark sites with Yellowbrick. They have no external access to data out there. So they need private LLMs. Okay, and
Mm.
so the pressure on the roadmap goes, well, so I'm now running this local Kubernetes cluster in my own data center. I want to wheel in GPU based hardware, and run, you know, a Llama based model or something like that, that's totally private, because I don't want my questions and my data being used to train OpenAI stuff. I don't want any leakage coming out potentially from that. So we're seeing more customers interested in, you know, private LLMs and running those locally, and how they can fit in with the Yellowbrick architecture.
Yeah, so potentially you could, I'm thinking here from a roadmap perspective, you could theoretically start to sort of uh, adjust or add a version of a private LLM into your deployments potentially as options, and
That's right. I mean,
have them
basically,
adjacent.
we call it bring your own LLM, BYOLLM.
Yeah, 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 yeah.
So
And you
that's
can,
exactly, you bring your own containerized LLM that runs on hardware in your own data center. So very much.
very, very interesting. So yeah, so it's more of a natural fit than, you know, than anything, I think, because ultimately what feeds these or the chatbots which leverage the model, the RAG is the data. And so if you can get that data quickly and efficiently, you're going to make the whole RAG process more efficient. And the thing that I find actually tinkering with this stuff as well is that when you go to do the call, typically to an API or whatever it might be, that's the slow part of the process, right? It's waiting to go and
Yeah.
query the API, authenticating. Am I getting the right data? Then it gets the JSON data. Then you're going to parse that and you're going to feed it back naturally. So what you're saying here is because of the efficiencies that Yellowbrick has and the speed of what you guys can operate at that industry speed, you know, that's going to be the benefit to customers looking to get the data in.
Yeah, I mean, bring it back to your first question at the top of the call, which was about what a data warehouse is. And, I said it's a centralized repository. Now, so if you centralized all of your critical data in one place, it makes it easy then, or easier to use that to train your models, right? A lot of the data from all your operational system is being streamed into something like Yellowbrick as well in real time, which means you can make real time inference based on that data as well. So I think data warehouses are at the center point of a lot of core business decisions and a great place to locate your future sort of generative AI workloads.
Actually, that's interesting. So the data streaming in as opposed to coming out. So just level set that just quickly because I think that's important to sort of, especially in the context of what we're just talking about with generative AI.
Yeah. Well, like I mentioned earlier, you go online and you make some online purchase. That goes through a transactional system and your credit card company ultimately and everything like that. But that transaction, that record of that transaction ends up in a data warehouse, and then you build up this historical, list of transactions that you want to run analytics on. So that's kind of why you get this streaming. But what we're really seeing, that was a traditional workload and use case for data warehousing. But data warehousing are moving closer to the edge and closer to being a real-time component. And you start to
Mm.
call these operational data systems, ODSs, where you're making kind of operational decisions based on real-time, near real-time data. And that's something that we do rather uniquely. So we're moving data warehousing from being an old, crusty historical analysis thing to something to being right on the front line, going like, I need to make a business decision now based
I
on the
get, I,
income
I get it,
data.
and speed and efficiency is the key there, right? So if you're taking data from an Internet of Things system, pulling it in, streaming it in, you want it to be stored efficiently in the structure that makes you guys quickly to be able to pull it out at the other end as efficiently as possible.
Spot
That's
on.
for me that's for me the value prop, and that's where the AI piece actually fits so beautifully here. I get it. And I hope other people get that as well because it just all clicked for me in that last sort of 2 minutes there. That's awesome. Um, with that, let's finish off by talking about the future. What you mentioned a little bit of roadmap stuff around AI and LLMs and bring your own LLMs and whatnot. But what does the next 12 to 18 months hold for Yellowbrick?
Yeah, well, the first thing we're doing that's really important is this kind of revisiting our roots by taking all of the good things we've done in Kubernetes in the public cloud and bringing that to an on-prem commodity-based hardware. Our customers want to be able to go to their hardware vendor of choice with a reference architecture provided by Yellowbrick in hand and acquire their own on-prem hardware. And also have on-prem hardware that's separated compute and storage. So it will run an on-prem object store as well. And they want to be able to elastically scale this stuff in their own data center. So bring all of those cloud-like experience, all those cloudy features of agility and all of that and elasticity, deploy them in their own data center. And Kubernetes enables that. And what's really exciting is this isn't if we build it, will they come? We've got pull through from new prospects and customers asking us and running us ragged, doing this as quickly as possible because they want it and need it, which is really exciting. So that's kind of the first thing on the agenda. Another thing that's going to come out this year, which I'm really, really excited about, is a totally free downloadable community edition version of
Oh yeah, I
Yellowbrick.
saw that. Awesome. Yeah. So
Yeah, so you can
how
run
does
it on
that
your own
work?
laptop. Yeah, you run it on your own laptop, or you can get it directly from one of the cloud marketplaces and run it for free yourself. It's a single node edition. It's limited to, I think it's 32 vCPUs. So,
It's pretty
but
significant.
it's pretty significant. And there's, yeah, be community support, totally free, and you can use it to just for development use cases, for
Mhm.
familiarizing yourself with Yellowbrick. Um, Use it in whichever way you want. So that'll be coming out in the next month or two.
Awesome.
Very excited about that. And then if you look kind of a little bit further afield, we've got the idea of bringing your own LLM. In fact, that's a broader piece there, which is bringing your own container-based analytics. So this is a way of bringing third-party applications and container-based software and integrate it with Yellowbrick in a very, very easy way. There's a couple of kind of I would say catch up things we're doing, because we're certainly not perfect. We haven't got a really good story around support for geospatial analytics.
Okay.
Have that in the product today. We're working on it. We'll deliver the first phase of that this year. So it means you'll be able to do geospatial joins and classic use cases. Looking up people and places and stuff like that, and joining that with
That's awesome.
location. Yeah.
Brilliant. Hey, this was great. I think, I love the fact that we've gone through the whole data warehousing, what it's about, and then at the end to actually understand where this fits today, especially with the AI piece. The community edition is really interesting. I definitely want to play with that, but I think everyone else should, just to get an idea of the benefit of this platform. We're going to run out of time. This has been great, Mark. Thanks for being on episode 93 of Great Things with Great Tech with Yellowbrick. Thanks a lot. Hey, just as a reminder, thanks for listening to this episode. Stay tuned for more episodes where we continue to highlight companies and technologies shaping our world. Don't forget to follow us on social media at G2WGT Podcast and visit g2wgt.com for more great content and all past episodes. If you enjoyed this episode, make sure to subscribe on your favorite podcast platform and on YouTube. Please spread the word, and if you feel like it, drop a review. Thanks for joining us, and we'll see you next time on Great Things with Great Tech.